Hello, this is John Schaap and welcome to this video in the updated 2021 version of AOS 8 video series. In this video we are going to have a look at installing and configuring redundant virtual mobility conductors and virtual mobility controllers on VMware ESXi. Let's go over the terminology changes that have happened over the years, and what used to be known as a mobility master is now called a mobility conductor, or MCr. MCRs are available either as physical or virtual device and cannot be mixed in case you install two for redundancy purposes. Managed devices are controllers and they are also available either as physical or appliance. This is the network setup that I'm going to build, and it consists of two redundant MCRs that you see on top with VRRP running between them to provide L2 redundancy. In the bottom of the diagram is a controller cluster of 3 VMCs. For the rest we will have 3 access points and also a ClearPass server and a Win2022 server for Active Directory, DHCP and DNS services. Mobility conductors are either virtual or appliances, and this slide shows the maximum capacity for each model. Each model supports a number of controllers, devices and clients. Virtual mobility controllers are always virtual and available in 4 different models, ranging from 10 to 1000 APs and 256 to 16,000 clients. Besides the virtual models, there's also a full range of appliances that can be used as mobility controllers, namely the 7000, the 7200 and the 9000 series. This slide shows what interfaces are available on a mobility conductor, and the next slide shows you what is available on the virtual mobility controller. So a mobility conductor only has 3 interfaces and a mobility controller has 4 interfaces. In my setup I'm only using Gigabit Ethernet 0/0/0 in trunk mode on all devices. Gigabit Ethernet 0/0/0 is network adapter 2 in VMware. Licenses are needed when you want to deploy an AOS 8 solution, and you have to contact your local Aruba representative if you want to get trial licenses or purchase them. The licenses in red are the most used ones, and the others are only used in special cases where there is a need for that functionality. For this video we are going to deploy a redundant mobility conductor, and that means that all licenses are installed only on the primary mobility conductor. You don't need licenses on the standby mobility conductor, and the cluster of virtual mobility controllers will use licenses from the mobility conductor due to centralized licensing running on that mobility conductor. In this video I will only show you how to install the first mobility conductor in VMware, as the other ones are done exactly the same. It's the same procedure. So give your machine a name, MCr-01. Then get your OVA file, that's still called MM for Mobility Master, but it is a mobility conductor. Next, select your data store, and then next, select your disk provisioning to tick and select your VM network that you're going to use. Then click next, check everything and click finish, and the machine will be installed for you. So after installation is finished, we need to check some things. So go to Edit Settings and go to Memory. And make sure that Reserve All Guest Memory is checked. You also see the network adapters here, 1, 2 and 3. We only use network adapter number 2, so turn off number 1 and number 3. And make sure that your network adapter 2 is connected to the right port group. In my case that's trunk to switch. Save that. And then go to Networking. Go to your port group and check that the security policy promiscuous mode, forwards transmits or MAC changes are all set to yes. If not, then you go here to security and say accept to all 3. That's it, and after you've done these settings, then you can power up the virtual machine for the first time. So open a console and power up the machine and let it finish. I'm going to speed up now till the end of the boot process. That's here. So we're going to fill in the name of the virtual machine. That's MCr-01. The VLAN ID that we're going to use is VLAN 201. This is the right port, but it's set to trunk mode, so type trunk here. Native VLAN we don't care about. Yes, we want an IP address, of course. That's going to be 10.10.201.21. Subnet mask and the gateway 10.10.201.1. DNS, that's 10.10.200.254. If we want IPv6, no, I don't want that. Country code, select yes. Time zone, in my case, is Europe, Amsterdam. Check the time, check the date, and set a password so that you can log in with the console and with SSH, and also via the WebUI. And say yes to accept all changes. And now these initial settings have been done, and the mobility conductor will reboot. So we'll come back after it has rebooted, and then we can log in to the WebUI. So it has fully booted, and now we can open the web browser and log in to the web user interface of the mobility conductor. You see the hierarchy again here. So we have /mm mobility conductor and the mobility conductor itself. You can see the different icons in front of the things. Manage networks, that's where the VMCs will come later. So this is the other one. This is MCr-02. And you see that we now have two individual mobility conductors. So what we're going to do is now first check some general settings, and then we're going to add them in a redundant fashion. So we check the clock, and we set an NTP server, because clock is for now not super important, but later on I can guarantee you want to have the clock set correctly. It's very efficient if you want to troubleshoot things with debugging, and also with certificate checking that comes later. Time is crucial, so if the time is not right, you will have issues. The same goes for DNS. You should always configure DNS. Spanning tree, I turn spanning tree off because I don't want it, so it only slows me down, so that's why I turn it off. And we're going to check the settings, and then we're going to deploy the changes. And then it's time to do the same on the other mobility conductor. So we go to number 2, and we go through system again, we do the clock thing again, and the DNS, check that it is set to the right DNS server. So that's DNS over here, that's set correctly, and again turn off spanning tree. And don't forget to hit pending changes and deploy changes, because otherwise they will not be in the running config of the mobility conductor. So we are back at mobility conductor number 1 right now, and we are now at the mobility conductor level, and that's where you will find the licenses. The licenses are already installed on this mobility conductor, but you see here that we have a PEF and an RF Protect license, but we do not have the feature enabled. So don't forget to also enable the feature bit if you did not do that when you installed the licenses, like I showed you in the first video of this series. You have to install the license and also enable the feature bit, otherwise the feature will not work. If you want to see how to get licenses in the system, watch video number 1, that's where I show how to do that. Interfaces. We're now back at the MCR level, by the way, not at MM level anymore. So we're going to do layer 2 redundancy. Give it an ID. I use the VLAN ID for that, 201. Give it a name, a password. Then the virtual IP address that we're going to use for this VRRP instance. The priority, this one is going to get priority 100, so that it will be the primary. And don't forget to set it up and to set the right VLAN. And also we have preemption enabled on this one, because I will always want this one to be the primary master. Going to do the same on MCr-02. So go to redundancy, click plus, give it the same ID, the same description, the same password of course as the other one, the same IP address because this is the virtual IP address shared between the two mobility conductors, but this one has priority 90 and it doesn't have preemption enabled because this is the standby mobility conductor. Deploy changes, and then we go back to mobility conductor number 1, and that's where we're going to set controller redundancy, because what we did up to now is just configure VRRP. So set it to 201, the IP address of the peer, and another key that you need to use here, because we're going to do the same at the other one, at MCr-02. So go to redundancy, conductor redundancy, and then the master VRP is 201, the peer IP address, that's the other mobility conductor, and the same key of course that's going to use to authenticate this session. Okay, hit save here, pending changes and deploy changes. So, one more thing we need to do at the mobility conductor level, and that is database synchronization. Turn it on and set a sync period of 30 or 15 minutes, whatever you want. Deploy changes, and immediately after you deploy the changes you see that the second mobility conductor came in. We're going to first look at the command line interface now of mobility conductor 01 to see how VRP is doing. So VRP 201, and this one is the master. We're going to see how master redundancy is doing, or conductor redundancy as it's called these days, and we see that it is master also. Then we go to MCr-02, do VRRP, show VRP, and we see that this one is the backup, and show conductor redundancy, and we see that it is also the backup for the conductor. Okay, go back to the first one, MCr-01, and show database synchronization to see if the database has already been synchronized. That's not the case. We have to wait until that 30 minutes passes by. So if we want to speed that up, we just type database synchronize, and then it immediately starts synchronizing the database, and you see that it has done one successful database synchronization here. And it's an L2 synchronization because we have L2 redundancy configured, not L3. So when we go back to the graphical user interface and refresh it, we'll see now under mobility conductor we see two mobility conductors, 01, which you can still configure from here, and 02, which will pop up this warning: configuration of the standby controller or conductor can only be done from that conductor or from mobility conductor. So now, from now on, we need to connect to 10.10.201.20, which is the virtual IP address of the active mobility conductor. And here you can see that everything is running fine, redundancy is working, and the next thing that we're going to do is now add virtual mobility controllers to this MCRs. So to do that, they will form an IPsec session, and we need to set an IPsec key here. I'm going to do here 0.0.00, that's a wildcard. For all controllers coming in, we set the IPsec key. You can do it per controller, then you have to type the IP address of the controller, or wildcard. So the virtual mobility controller has fully booted, and it's now starting the zero-touch provisioning process. We're going to stop that by typing full setup. And that brings us to the initial setup dialog, where we first going to type in the host name of the system, VMC-03. It's an MD managed by an MCR. You have to type the MCR's IP address, and that is in this case the virtual IP address of the VRP session that I run between the MCRs. It's an MM or MCr. Is this a VPN concentrator? No. This is no. It's a virtual mobility conductor. And then you have to type in the key that we just typed in with the wildcard on the mobility conductor. No layer 3 redundancy. The VLAN ID of the uplink is 202 in this case. And it's also trunk port. Native VLAN is fine. Then we type the static IP address that we're going to give this virtual mobility controller. So that's 10.10.203.33, net mask and gateway. And the DNS IP address. V6, no we don't want V6. Then a port channel, no we don't want that. Netherlands is yes, that's correct. Time zone is Europe, Amsterdam in this case. Check the time, check the date. Create an admin account, very important, so that you can log in to the system. And then accept the changes, and then it will reboot. So when all virtual mobility controllers have rebooted, you will see that they all are showing up in the mobility conductor, but there's nothing much to see if you click the tree. So let's go to the command line interface and type show switches. That will show you the whole system. So the conductor, the standby conductor, and 3 MDs, managed devices, also known as virtual mobility controllers. But the configuration state is UNK, unknown, that means. So what you need is to copy the MAC address from here, then go back to the graphical user interface, and first we're going to build the hierarchy for our managed network. So we're first going to create some groups. So we start with the company where this is all going to be installed. In this case I will use our parent company HPE. And then under HPE I will create 3 other groups. So one will be called EMEA for all the devices in EMEA. We will have a US group. Now this is not how you need to do it. It all depends on what you're building and how you're going to build it. This is very important to understand that this is hierarchical. Here the config will be built hierarchical. So it starts at managed network, that folder. Then underneath that you will have HPE, and underneath HPE you will have the 3 territories, APJ, EMEA, US and US. So now we're going to add a controller. So copy the MAC address in the MAC address field. The host name is VMC-01 for this one, and very important, select the correct type. So this is an MCVA, a virtual appliance. And you're going to repeat this thing 3 times. So we're going to add VMC-02, go back to the command line interface and copy the MAC address. And the correct type, and submit, and one more time number 3. So you see how the whole hierarchy is building up. It starts with managed network, under that HPE, under that the 3 territories, and then all 3 controllers in this case will be in EMEA. So later on we're going to move these 3 controllers into a cluster. That's not going to be in this video, that will be the next video. But this is how it will look then. Now you have to deploy, or depending changes, deploy them. And then you need to wait for a couple of minutes. So after a couple of minutes you will see that 3 controllers show up here when you select the right folder, EMEA in this case. And you see 3 controllers are up. You can click it here. And then you can click the individual ones. You see that they all run 8.9. If you want to know more about the device, click it. It shows you more details about the device. It shows you the country code, which ports are up and down. Go back here. You can also go to the individual ones. You will see this screen here, like this. Or click the controller list here and you come to that same screen. So if you look at the command line interface of the mobility conductor, and if you now do show switches, it shows that configuration state for all 5 is now update successful. They're all 5 up, they run the same version, and very important, whenever you change something in the config on the mobility conductor, that config is synchronized to the standby conductor and also to all your managed devices. So the config ID, in this case it's 11, should always be the same on every device. If some managed device fails to synchronize, it will lag behind, so then you will see all the other ones at 12, and if the other one stays at 11, that means that it's not synchronizing anymore, so there's something wrong there. What else can you do here? You can do show crypto IPsec SA, because there is an IPsec tunnel between the managed devices and the mobility conductor. And you see that here, there's 4 IPsec tunnels. One is this one that comes from the standby conductor, and the others, they come from 31, 32 and 33, and those are the managed devices that you also see here. This brings us to the end of the video, so let's recap what we have done up to now. We've installed 2 MCRs and created the VRRP instance between them, and also configured MCr redundancy. Then we installed 3 VMCs and configured them as managed device on the MCR. So that creates a total of 4 IPsec sessions. 1 session between MCr-02 and MCr-01, and 3 sessions between the 3 VMCs and the virtual IP address of the MCR. In the next video we are going to configure the 3 VMCs into a controller cluster, install some IPs and create a wireless network that will terminate on the controller cluster. Please like, subscribe and let me know in the comments what you think. Bye for now.